Good afternoon, Manandal. This is Anjan Kumar from EC department, and today I'm discussing about the continuation of last lecture, that is upsampling. Okay, uh, I think yesterday stop video here only, but I'm starting with this only. Okay, the signal obtained by after filtering is given by V of n is equal to summation k is equal to minus infinite to infinite and h of k x of n minus k. Okay, this is the signal obtained after filtering. Clear? Next, output sample, that means downsampled signal y of n, and this should be is equal to V of n into d. This is the decimation. Okay, and that should be is equal to summation k equal to infinite to infinite, and this h of k x of nd minus, wherever n is there in above equation, you simply substitute in place of n nd. Okay, n into d. Okay, for example, you consider a factor of 2 downsampler, 2d. In place of d you simply substitute 2 downsampler, then this 2 you directly substitute in equation 8. So in this equation you simply substitute d is equal to 2. Okay, wherever d is there you simply substitute 2. That is 1 by d. 1 by d means 1 by 2. Summation k equals 0 to 1 x of e power of j omega minus 2 pi k by 2, and this is equation is previously. Okay, so after simplification this equation we are getting like this. Okay, after y of e power j omega is equal 1 by 2, 1 by d means x of e power j omega by 2 plus x of e power of x of minus e power of j omega by 2. After simplification these two. Okay, how to simplify this one? Just to expand this summation. Okay, whenever you expand this summation, after we are getting like this only. So k equals 0 to 1, wherever k is 0, wherever k is seeing in this equation, you simply substitute 0 to 1. That means 0th term and 1th term. K is equal to 0, this value, k is equal to 1, this value. Clear? Okay, the second term, this one is the second term of this equation. X of e power of minus j omega by 2 is simply obtained, which is simply obtained by shifting the first term x of e power of j omega by 2 to the right by an amount of 2 pi. This is very important. Okay, and this is the upsampling. This is the continuation for upsampling. So what is upsampling? Already yesterday detailed explanation is given. Okay, what is upsampling? Upsampling means simply just to increase the samples, that means increasing the sampling rate of discrete time signal is called as upsampling. Okay, the sampling rate of discrete time signals can be increased by a factor I by placing I minus 1 equally spaced zeros between each pair of sample, whereas downsampling means just you to decreasing the samples. Okay, here increasing the samples. Okay, this is the mathematical representation of upsampling. Okay, and that is y of n is equal to x of n by l, and this is the functional representation of a signal. y of n is equal to functional representation of x of n by l, and this should be satisfied in this region only. Okay, so y of n is 0 for otherwise. This is the mathematical representation for upsampling, and this is the symbol for upsampling. Okay, upsampling means just to upwards. Okay, x of n is the input and y of n is the output signal. Okay, this is a symbol for upsampler. For example, you take a sequence, input sequence, x of n is equal to 1 2 3 comma 1 2 3 and so on. Okay, and then to increase the two samples, that means actually this is the sequence, I mean this is the equation. What is the equation? Y of n is equal to x of n. This is the upsampling equation. Okay, you remember this one. Okay, here to increase the two samples from this equation and from this sequence, you increase the two samples, and that means in between 1 and 2 just you simply put a 0. That means two samples are increased. Clear? Okay, after 2 0, after 3 0, after 1 0, again after 2 0, after 3 0, after 1 0. So this is continuously processing. Okay, and this is x of n by 2. That means you see, instead of this sequence we are getting like this only. How to get? Just to increase the samples, to increase the number of samples. That number of means only two samples. Here n by 2 means 2. For example, n by 3, that means 3 samples to increase the input sequence. Whenever x of n by 3 is there, this is occur from the input sequence. Okay, just you see the diagrams, you can easily understand. Okay, usually an anti-imaging filter is to be kept after the upsampler to remove the unwanted image developed due to upsampling, whereas downsampling, on that place we are using anti-aliasing filter, but here upsampling, but in upsampling anti-imaging filter are used. Okay, you remember that the anti-imaging filter and the upsampler together is called as a interpolator. Okay, next, interpolator comprises two blocks such as upsampler and anti-imaging filter. Clear? Upsampler is used to increase the sampling rate